Okay, so again, welcome back. Hope you guys had an alright snow day. Hope everyone got here okay. Was it tough getting here today?
Yeah, I got here like at 10:30.
The bus driver got pushed.
Yeah, she got assaulted.
You guys were there on that
Yeah,
bus?
I witnessed it. I saw it.
Jeez. Was there anybody that you know that hit him?
I don't know. She just started running. She left her kids behind. She's a horrible mom.
Alright, well that's sad. We all get a little crazy in the weather. But today, again, what I want to do is I want to do a little bit of a review of what we did on Tuesday, but I want to show you another way of thinking about it. And in that, I want to make sure you guys are solid, especially those who are here, are really feeling solid with perfect inelastic collisions and regular inelastic collisions in terms of the math, in terms of the algebra that we have to do, and in terms of the conceptual as well. So we're going to do the same objective. We read that one on Tuesday, but if you want to remember, identify analyze explosions and perfectly inelastic collisions. And by analyze, I also mean algebraically analyze. So, in your notes that I handed you, you have this picture here. Does everyone have a note? Anybody not have it? Good, you got some too? Today, you got this one, third down, page 13. All right, cool. In your notes, I have a picture, another representation of a perfectly inelastic collision. Now, how do we know this is a perfectly inelastic collision? What about this situation? I have two objects coming at each other. They collide and they stick together. What about this tells us it's perfectly inelastic? Let's think back. See Zamar looking back in the notes, which is awesome. All right, let's think back. What means perfectly?
They stick together.
They stick together, right? That's what makes sure that it's perfect. So this fact here, and that helps us when we do our conservation of momentum. So let's zero in on before and after, and then we'll talk about what's true about how the momentum is related. So before, you have a box there, right? Before, what is the equation for the momentum of the two objects? Well, I have m1 and I have v1. I have m2 and I have v2. So how do I write the total momentum before? Or P naught. How do I write that? I have two objects, I have two masses, and two velocities. So how do I do that together? What should I do? Let's remember back. We did this on our quiz. You guys all did this really well on your quiz. We just added the two momentums together. So what does that look like if I add the two together? Bianca, want to help us out?
Okay. Is it PF?
So we're just saying if that's true, I'm going to get to that in a second. But just think in terms of before they collide, I have two objects. I have two momentums. I want to know the total momentum. So how do I find the total momentum? I gave you a little hint. I said you add, right? So I'm going to add the momentum of this one plus the momentum of that one. What's that going to look like? What's our basic equation for momentum?
Is it M1 plus M2?
Close. M1. That's
Plus
if they were
V1.
stuck together.
Plus V1.
M1 times V1.
And then with the
Not yet. Plus
this
is before.
Plus M2 times V2.
M2 V2. So what that is, we're going to get to the rest of it in a second what you're looking at. What that is that's the momentum before they collide. That's how much momentum it has before they collide. I took the mass of the first one, multiplied by its velocity, then took the mass of the second one by its velocity. Pictured here, what would V2 be? Would it be positive or would it be negative? What do you think? You're right. You want to help us out? V2, what do you think that would be? Positive or negative? Negative. Why? Because it's going to the left. So that means that this would actually become M1 V1 minus M2 V2 when we make V2 negative. All right? So after they collide, our final momentum. We have two objects stuck together, moving with one velocity. Then, what do? Well, we know the momentum is m times v. So that means that I can do my mass, but my mass is my total mass, because they're stuck together. That's the key term there. So Marilyn, help us out. What do I do when they're stuck together for the total mass? How do I add the masses together? What should I? I want to know what the total mass is. I have two masses. I add them together, right? So how can I write that using what I know here? I have M1 and M2. So I want to help her out. What should I do? We did this Tuesday.
M1 plus M2.
That's it. Yeah. I'm don't want you to think I'm asking you something too crazy. M1 plus M2.
And then you do V
Prime.
prime.
Okay.
And
What?
then you cross that out.
What does that prime mean? What does that prime mean? We talked about this as well. What does the prime mean in here? Why did I make my velocity prime? That's to indicate something for us. What does that indicate? Do you remember from Tuesday? Prime. Well, what's the difference here? This is before, this is after. Same thing. That's what our prime is saying. Prime tells you it's a velocity that's after the collision. No matter what type of collision you have, anytime we set up this, our prime means after the collision. So that prime tells you that's the velocity of the two objects after they collide, not before. That's why we use the prime. Sometimes, especially in other types of collisions, you'll see we have two masses and they each have a velocity before and after. It can get a little messy, so we use primes to make sure. So now we're going to use our conservation of momentum to set up the equation here. So P naught equals PF. Say we're solving for this velocity here. P naught equals PF. Well, I could set those two things equal to each other now. So the thought process I went through was find the total momentum before, set it equal to the total momentum after. Because the momentum doesn't change. That's why we talk about momentum. That's the beauty of it. So I do M1 V1 plus M2 V2 equals M1 plus M2 V prime. So now I'm going to solve for this. What should I do to solve for that? I have multiplication of a total mass times V prime. I want to get V prime by itself. What should I do to solve for it? Kadam?
Divide M1 plus M2.
Yep. So I divide by M1 plus M2, and then I'll get my V prime. Okay? So, we can solve for V prime that way. Now, you don't have to memorize this equation. You don't have to memorize the step process. You have to be able to think through it critically. What did I do? I found the momentum before, added it up. Found the momentum after, because I knew they stuck together, and I solved for that V prime. Okay? So I want us to be able, so that should be in your conservation of momentum for PICs. That should be the piece right there, this little last bit. So what I want you guys to do now, today, is we're going to get a little practice with that, and then we'll look at a perfect, or just a regular inelastic collision. All right, so I want to give you guys some time to get some practice, and then we'll look at a perfectly inelastic collision. Okay? So, any questions about this? I know I finished it a little quick, but any questions about that before you guys get a little practice in together? One last thing I want to ask. If instead I knew the final velocity of the two, but I want to know what V1 was, what would I have to do instead? That would be different. If I knew what V prime was, but I want to know what V1 was, how would I solve for that? What would I do that was different? What do you think? Let's look back here. P naught equals PF. That would be the same. Set this up the same. But from this step, the green down below, what would I have to do differently?
Divided by M2.
So I'd be looking for V1, right?
Uh-huh.
So first I have to get rid of the addition that I have there. Then I'd have to get rid of the M1.
Because V1 equal, what equals V1 is M2 times V2 prime over
If there were-
M1.
Go ahead. That's if we had this set up. You're looking at your explosion example right there, which is a little different. Okay? It's very similar, but it's a little different. You don't want to just kind of get to that. You want to look here. Well, if I know this, I know that, I just want to subtract M2, V2. And then I'm going to divide M1. All right? So get a little bit of practice with this. You have 1, 2, 3 that are all those types of problems. I'm going to give you guys 10 minutes to work on those 3. After that, we'll come back and we'll talk about number 4. All right? We'll talk about number 4. We'll see if you have time for you guys to do some measurements with this. Okay? So go ahead. and get started on 1, 2, and 3.
My baby.
I'll be around to help. You guys can move around to